Good morning, everyone, and welcome to today's edition of Toolbox Tuesday. Today's topic on air quality. My name is Kieran Greening. I am a safety advisor out of the Saskatoon office. I deal with a few different regions. If you watched any of these previous webinars, you'll know exactly which ones, but we'll talk about them anyways. In Prince Albert, north of Saskatoon here, go west out to Macklin area, east out to Humboldt, and then some of the greater Saskatoon area companies as well. So if you're in those regions and you need some help, reach out and ask for me. Without further ado, we'll get started on today's topic, which is air quality. So it's in regards to indoor and outdoor air quality, and to gain a little bit of awareness on what that means, some of the hazards, some methods of control. It's not exhaustive. It's not going to be every single control out there, but it's going to be a good head start if you're looking to get some knowledge on what air quality is all about. So like I said, there's a few things. What affects the air quality, hazard awareness, control methods, because there's several ways to control indoor and outdoor air quality, because when we work in construction demolition, there's a lot of different hazards that arise with air quality. So we're going to talk about some of those materials that affect hazard awareness, basic controls, and some methods that'll help all the stakeholders in your company. So now we'll take a look at the hierarchy of controls. This is a main focal point of health and safety. Any safety professional you might talk to has referenced or seen this numerous times. So if we look at the top, elimination, substitution are the two best methods of control. If you look on the left-hand side there's a bar that goes from most effective to least effective. So the ones we're going to be taking a look at today are engineering controls, administrative controls, and PPE. So if an engineering control is the most effective control without taking the hazard out of the equation. So you might have to isolate people from the hazard. Administrative controls, you're going to change the way people work. You're going to train them, potentially do some other stuff. And PPE, the things we all know and love, respirators, different pieces, SCBAs for hazards in respiratory controls. So we'll move right on to the next thing. So we'll talk about outdoor air quality. So when it comes to the air we breathe outside, there are a few things that affect the quality of it. Some of these items are the weather, from extreme heat, extreme cold, cigarette smoke, cigars, other things people put in their mouths, accumulated exhaust from machinery, from factories, silica dust from cutting operations, whether it be concrete, brick cutting, your neighbor chipping away at his driveway, pollen, air pollution like vehicles, exhausts, forest fires that cause smoke, volcanic eruptions, low-lying gases outside. If you work or live anywhere with valleys and stuff, there's potential for low-lying gases in other trenches and holes. So some of these scenarios can depend on the time of year, environmental factors in different places, and other concerns there, but not every person has the same tolerance to outdoor air quality. Some people have asthma or a tendency to get different respiratory infections. So it's important to know your workers, to know who they are, what they do, and what can affect them. For example, the year we had that smoke and it was pretty intense, there was good chance that if you were working outside, doing anything that causes extreme stress on the body, anything like that, there's a good chance that you will have debris in your lungs. And whether your mucociliary escalator can keep up with it is in question. So it's important to understand the hazards and choose what you do based on that. So incorporating controls may be slightly more difficult than indoor air quality situations, because you can't exhaust all of the outside air for new air. Potentially, it would just be the same air you're recirculating into the same area. So luckily, most of our environmental hazards are ventilated quite quickly due to convection or air movement, which is a natural flow of air, wind, but other allergens such as pollen may cause allergies that may require medications to control. So there's different situations for different people, and we got to make sure that we understand and deal with them appropriately. So one thing to check before we go and work outside, different occasion, is to check the air quality. So there's different websites that will tell you what the air quality is in a certain given area. So these places generally partner with the government. I know for a fact that the Saskatchewan government partners with a couple different places to get you up-to-date air quality. So it just tells you the size of respiratory particles that could enter your lungs and the chance that there is. So taking a look at this will give you a good idea on how much work you should be doing in a certain day, the risk level, and then you can go from there. Indoor air quality. So indoor air quality has a significantly higher number of potential hazards. This is due to there being walls, and air cannot permeate through the walls. So some of the potential hazards or items that cause hazards, mind you, are chemicals, asbestos, silica dusts, molds, fungi, bacteria, gases, vapors, odors, extremely warm or cold air, hydrogen sulfide, H2S gas, carbon monoxide, carbon dioxide, fiberglass, asbestos, volatile organic compounds or VOCs, solvents, and many more. So although indoor air quality is more hazardous due to the potential concentrations in the air that you breathe, there's also quite a few more ways to control those hazards. So over some of the next few slides, we're going to go over some controls and talk about how to best safely work around these things, potentially. So one of the main things is in a high concentration of emission, let's say for a good example is a welder, it's a great control to have a permanent local exhaust ventilation system. So as you can see there, the stack fan duct, air cleaner and hood, it pulls the air through and it vents outside. So oftentimes someone will have to be involved in some level of expertise, such as an industrial hygienist, to ensure that where that goes outside, that it doesn't go into another airway. So a lot of the time, air from that goes ventilated outside gets recirculated inside if it's not located properly with the right kind of ducts. So there's a lot of things to be aware of here. So these are really good when there's bigger particles that'll settle more quickly. The toxicity of the contaminant is high, like welding fumes. Environmental conditions are extreme, and cost of heating large volumes would be excessive. So if you have one welding operation in a shop where that's the only time it happens, it may not be worthwhile to get rid of all of the air all of the time. So this is a solution for there. So we'll move on and look at general exhaust ventilation. So general exhaust ventilation is most commonly referred to as HVAC, or heating, ventilation, and air conditioning. These systems are a very modern way of controlling the temperature in a building. They do dilute certain contaminants, but these potentially might not keep up with hazards that are generated elsewhere. So if we're going to look at figuring out what we can do if we have an operation that creates these things, is we're going to look at dilution ventilation. So oftentimes we'll hear that general exhaust and dilution ventilation are used interchangeably, but in professional reference, dilution ventilation best describes anything from windows and doors to open, that a system designed to move air in a certain way. So in the picture on the bottom left here, you'll see a fan that pushes air in, it forces it in through that duct at the bottom where the low-lying gases may go, and there's an exhaust fan on the other side of the working situation. So in this perfect world here, you get the best airflow that takes the hazardous gases out of the room quickly. So these are better if the toxicity of the contaminant is low and it just accumulates on the floor. The emissions are mainly vapors or gases or respirable size aerosols. So when you say respirable, it's less than 5 nanometers, which then can be sent into the alveoli region of your lungs, which is not good. If you want more information on respiratory hazards, check out some of our other respiratory presentations. To get back on track here, to remove heat from an area by flushing outdoor air, that's another thing. So if machines bring a lot of heat when they turn on, this is a good way of getting rid of it. So a good scenario where this would be used is a car garage. So if you ever have started your car in the garage, you'll know that it quite quickly creates a lot of smoke or exhaust fumes. Oftentimes those contain carbon monoxide, which is a byproduct of unburned hydrocarbons through the combustion process. So they'll accumulate as a low-lying gas. If you have your garage door open, air is able to get in and remove that quicker than if the door was completely closed. And a lot of times it can be a fatal mistake if you leave the garage door down when the car is running in there. So to combat this, we just open the door and let that breathable air in. And that's just a perfect example of dilution ventilation at home. So job site ventilation, unfortunately, we do see a lot of job sites with contaminants, but ventilation on these job sites can be very important and part of that healthy part of health and safety. So as you know, employers are required to provide a health and safe workplace. And part of that is providing respirable air for everybody. So a lot of thought must go into a system like this. Generally, a qualified person, an industrial hygienist, or someone with the training will design a system that removes enough air and has enough dilution for a certain area. But oftentimes these systems are going to look like this, a fan with the big hose. So for some tasks, there's a low risk. So if you have a building with bare studs, it's a good chance that the convection of the wind will ventilate for you. That's not to say that if you're working with an extremely volatile substance that you're fine. You have to check the SDS, check the recommended usages, and find out if it's hazardous, even if there is good ventilation. In that situation, you may be required to go further and wear personal protective equipment. So in a higher risk situation, such as a hazardous confined space, companies may create some sort of fume and you are required to ventilate. If you can't ventilate, that's when you have to don atmosphere supplying respirators or SCBAs. So sometimes the best situation is to use ventilation. And ventilation will work, but again, contacting an industrial hygienist, qualified person, making sure that you cover those bases of, am I actually removing the contaminant? Because it's extremely hazardous to have someone go into an area where if they stop breathing and they go in there and someone else tries to rescue them, you could have a pile of bodies, as we all know from different respiratory protection courses and stuff like that. So it's important to also wear air monitoring devices. A lot of times there are a whole bunch of different pieces of technology. Most recently, there is silica detecting monitors that go give you live updates versus previous where you have to take air samples from respiratory zone over an 8-hour shift. and take it to a laboratory. So now there are things in place, and it's just as simple as reaching out to those experts who have that field knowledge and they keep up with those things. So we'll move to the next thing. We just went over some engineering controls and ventilation. So we're going to look at administrative controls, as they're called. So administrative controls are as simple as a work practice control, so changing the way people work. So we could do a few things like a work schedule. So if exposure to indoor pollutants can't be reduced through scheduling, then we'll do it that way. So this way we can reduce the amount of time a worker is exposed to a pollutant. And some pollutants have what's called a no effect limit. So if it won't have an effect over a certain period of time, and it accumulates, and that's when it has a problem. So with this knowledge, we can design work schedules. Potentially, we can also provide training, which is a big piece of everything, giving workers awareness, giving them the awareness and the training to wear PPE, to understand ventilation systems, to consult experts. So when we train people, we really give them an understanding of how to work properly, and we set an example of how we want them to work as well. And housekeeping, so a very common practice to prevent dirt, dust, aerosols, stuff from accumulating in the atmosphere is to store them properly, to remove them, to control dust properly. So ensuring you have the right practices to use housekeeping to your advantage, then you can almost prevent these things from becoming airborne like a second time, I suppose. So now we'll look at PPE. In this case, it's going to be respiratory protection. So the three different pieces here, we have a full face mask, a half mask, and an N95 respirator. So all these are classified as respirators because they remove certain particulates and they are given a rating. So we're going to talk about the ratings quickly. So the N in N95 means it's not resistant to oil. So if there's an oil in the atmosphere, it will go through and permeate through the mask and go into your lungs. So if you see it with an R instead of an N, it means some resistance to oil, and P means strongly resistant to oil. 95 is just the efficiency, so it reduces 95% of airborne particulates. You might also see NP or R 99 or 100. 99 means it does 99% of pollutants, and 100 means it does 99.7% of airborne contaminants. So it's important to know which pieces you need for which for what you're doing. In other situations, you might get to where you need organic vapor, different situations where you need gas masks. Oftentimes, respiratory protection is very broad, and you're going to have to consult someone with the expertise on what you need. So in partnership with those SDS sheets in that WMIS system, you're going to want to make sure that you understand all of the hazards going into your workday. So just to conclude here, I want to thank everybody for participating in this webinar. I hope you got something out of it. I know I had fun putting it together. So if you will, please join us tomorrow for the newest edition of Webinar Wednesday, where Bill Gazelle will be presenting information on exposure control plans. Thank you so much, everyone, and have a great day.